No, ma'am.
Hey, I
Now
started,
started,
ma.
ma'am.
Now it started,
Now
ma'am.
started
Yeah, thank you, ma.
recording.
Now the first problem, write down all of you. The first problem, reduce the quadratic form reduce the quadratic form 3x square plus 5y square 3x square plus 5y square plus 3z square minus 2yz
Ma'am, video is
minus
blurring, ma'am.
wait I am doing writing the question then after 2yz plus 2zx plus 2zx minus 2xy. While a minute, I will make a change more, please. To the canonical form, to the canonical form by orthogonal reduction. By orthogonal reduction. I think it is clear. Okay.
Yes, ma'am. Clear.
Okay, ma. See the question. 3x square plus 5y square plus 3z square minus 2yz plus 2zx minus 2xy to the canonical form by orthogonal reduction. How can we identify the given problem is a quadratic form? Already is there in the quadratic form. We need to change the canonical form. What is canonical form? That nothing but the normal form by using the orthogonal reduction. What is orthogonal reduction? The orthogonal reduction is P inverse equals to P transpose. It is clear, all of you? It is clear, ma?
Yes, ma'am.
Now go for the solution here. The first point. What is the first point? We need to write the matrix of the given one. Okay. So the capital A equals to how many variables are there in this? 3 variables x, y, z. It is clear. Again, in vertical form also we can write it as x, y, z. X square coefficient here it is the 3, y square coefficient here it is the 5, z square coefficient again it is the 3. Clear? Now I'm going to write yz. Yz, y into z, the coefficient is minus 2. Again we have to divide with the 2. Yz is equals to z by. So this is also minus 2 by 2. It is clear? Now then go for next one. 2zx. Zx, the coefficient is the 2. Again we divide with the 2. Zx equals to xz. So that is 2 by 2. I'm going to the last one. Minus 2xy. xy. So coefficient is minus 2 and divide with the 2. Minus 2 by 2. It is clear? Now I'm going to write here capital A equals to 3 minus 1, 1. Minus 1, 5 minus 1. 1 minus 1, 3. So this is a symmetric matrix mark completely. Okay. And we go for find the characteristic equation for finding of the eigenvalues. Okay. Now the characteristic equation is det of A minus lambda I equals to 0. Now 3 minus lambda minus 1, 1. Minus 1, 5 minus lambda minus 1, 1 minus 1, 3 minus lambda, which is equals to 0. By simplification, we are getting the lambda values. Please do the simplification, ma. This is a very length problem. So I'm skipping that total solving procedure. Directly I'm going to write The eigenvalues are lambda equals to 2, 3 and 6. Already this problem we done in the previous method diagonalization. The eigenvalues are 2, 3, 6. It is clear? The step 1, step 2 completed. Then go for the step 3. What is the step 3 ma? Finding the eigenvectors. Okay na? So this is a step 1 and here it is the step 2. Then we go for the step 3. Finding the eigenvectors. Okay na? To find eigenvectors. Here, first of all, case 1 in this. What is the case 1? Corresponding to. First eigenvalue is lambda equals to 2. It is clear? Finding the eigenvector corresponding to lambda equals to 2. Then the characteristic polynomial equation is what ma here? A minus lambda I matrix notation which is equals to 0. See, I'm going to write here 3 minus lambda minus 1, 1, minus 1, 5 minus lambda minus 1, 1 minus 1, 3 minus lambda, and into variable matrix. Already we know that in the quadratic form x, y, z are involving. So that is equals to zeros. It is clear all of you? Okay. Now here I'm going to substitute put lambda equals to first eigenvalue here 3 minus 2 1 minus 1 1 minus 1 5 minus 2 is the 3, it is minus 1 third row 1 minus 1 3 minus 2 is the 1. It is clear all of you? Into x y z and which is equals to zeros. Clear? Now I'm going to selecting the first two rows. I'm going to selecting the first two rows. It is clear? Okay. For solving and finding the variable values. It is clear? Then I'm going to write here. So the values are here. I'm going to write here 1 minus 1 1 and minus 1 3 minus 1. Again I'm going to write this one. The last we can write the first values in the again first here 1 minus 1. It is clear? Then x by, tell me, so this is the x and this is the y, here it is the z. What is x value denominator? 1 minus 3. It is clear? And y by minus 1 plus 1 0. Okay, and z by 3 minus 1 which is equals to kc. Okay, now x by minus 2, x by minus 2, y by 0 and z by 2. It is clear all of you? Which is equals to k. Then 2 ones are 2 ones are. Now the first eigenvector x1 which is equals to minus 1 0 1. Okay, directly in the case 1 only we need to find the normalized value. What is the normalized value? Tell me ma. Any guess? Are you following all of you?
Yes, ma'am.
Normalized value, tell me.
Minus 1 by root 2, 0 by root 1.
Normalized value is under root of minus 1 whole square plus 1 square. It is clear, so that is the root 2. Now capital X1, this is what normalized vector. Normalized vector. It is clear? So x1 equals to, very good ma, minus 1 by root 2, 0, 1 by root 2. The procedure is completed for case 1. Okay. Now we go for the case 2. What is case 2 here? For lambda equals to 3, we need to find the eigenvector. Okay, now Now the matrix form is A minus lambda I into x equals to 0. Again I'm going to write here 3 minus lambda minus 1 1 minus 1 5 minus lambda minus 1 1 minus 1 3 minus lambda. It is clear? Into x y z which is equals to zeros. It is clear? Now I'm going to substitute here, put lambda equals to what here? 3. Then take a pick, all of you, please. I'm going to rub.
Question is not visible.
Reduce the quadratic form. Quadratic form also not visible. Now,
No, ma'am, not visible.
ఇప్పుడు ఓకేనా?
Okay, ma'am.
Completed?
Complete one, ma'am.
I'm going to rub this total mark. Okay? Next, for lambda equals to 3, it is clear? Lambda equals to 3, we need to find the eigenvector. Now going to substitute lambda equals to 3 here. So 0 minus 1, 1. Minus 1, 5 minus 3, it is 2. And minus 1 here. 1 minus 1, 3 minus 3, already it is the 0. Clear? Into x, y, z, which is equals to zeros. Okay, again I'm going to take the first two rows because of the completely two rows having the 5 variable coefficients are non-zero. Then for solving of xyz, I'm going to take the first two rows here, these two rows. Again minus 1, 2, minus 1. I'm going to write this one is the first place. 0 minus 1. Here it is x and here it is y. This one is the z. Okay, now x by 1 minus 2 minus 1, y by minus 1 0, that is minus 1, z by 0 minus 1, here it is a minus 1. It is clear, all of you? Then directly you can write down for negative values only. Then the eigenvector is what here x2 equals to minus 1 minus 1 minus 1. Don't cancellation with the minus 1. Directly you can write down that is the eigenvector. Now what is the normalized value? What is the normalized value? It is clear. Under root of minus 1. Yes.
Root 3, ma'am.
Very good. So that is root 3. Okay. Now normalized vector. Normalized eigenvector. So that is x2 minus 1 by root 3, minus 1 by root 3, again minus 1 by root 3. The second case totally completed. Now we are going to find the third case. Okay, go for the case 3. What is the case 3 here? For lambda equals to 6. It is clear? The last eigenvalue is the 6. Okay, now?
Yes, ma'am.
Next. Now the matrix form is A minus lambda I into x equals to 0. Again substitute 3 minus lambda minus 1 1 minus 1 5 minus lambda minus 1 1 minus 1 3 minus lambda into x y z equals to 0. It is clear, all of you? Any more doubts more in this? This topic is completed and you done in the mid-one examinations, diagonalization, right? And we are going to substitute lambda equals to 6. 3 minus 6 is the minus 3. It is clear? Minus 1, 1. Minus 1, 5 minus 6 is the minus 1. Again minus 1. 1 minus 1, 3 minus 6 is the minus 3. Completed, ma. And into variable matrix x, y, z, which is equals to zeros. Clear? Again, I am going to selecting the first two rows. The first two rows for simplification. Minus 3, minus 1, 1, minus 1, minus 1, minus 1. Again, I am going to write this here, minus 3, minus 1. Here it is x calculation, y calculation, and here it is the z calculation. Okay. Then x by minus 1, minus 1, 1. 1 plus 1, 2. It is clear? Y by minus 1, minus 3, minus 4. And z by 3 minus 1, 2. It is clear, all of you? Then it is cancellation with the 2. 2 ones are 2 twos are 2 ones are. Then x3 eigenvector is 1 minus 2, 1. It is clear? Now, the normalized value. Video struck ainama?
It's
Yes,
not
ma'am.
visible, ma'am.
Struck ainda visible.
Struck in, ma'am.
Stuck, ma'am.
Now it is clear.
Yes, ma'am.
Yes, ma'am.
Yes. Now the normalized value. Normalized value is what ma here? Under root of 1 square plus minus 2 whole square plus 1 square. So that is equals to 4 plus 1, 5 plus 1, 6. Root 6 is the normalized value. Then normalized eigenvector. Normalized eigenvector x3, which is equals to what here? 1 by root 6 minus 2 by root 6, again 1 by root 6. The total 3 normalized eigenvectors completed. Now then we go for the next step. What is the next step? Fourth or third one? Then we go for the fourth step. What is the fourth step? Write the capital P matrix. Write capital P, which is normalized vector. Normalized matrix. What is normalized matrix? Which is formed by the normalized eigenvectors. Capital P, which is equals to norm x1, norm x2, here norm x3. It is clear? Now I'm going to write capital P equals to the first one. Oh, I think the first one rub చేశాను. First one ఎవరికైనా గుర్తుందామా చెప్పండి. First one ఏంటి? నా ఐగన్ వాల్యూ 2 కదా. 3 minus 2, 1, minus 1, 1, minus 1, 3, minus 1.
Minus 1 by root 2, 0,
Yes,
1 by root 2, ma'am.
Okay. Minus 1 by root 2, 0, 1 by root 2. Clear? Okay. Next, x2 eigenvector, that is normalized eigenvector, minus 1 by root 3, minus 1 by root 3, minus 1 by root 3. Next, third eigenvector, 1 by root 6, minus 2 by root 6, 1 by root 6, which is capital P. Okay. Since capital A is symmetric and capital P is orthogonal, then P transpose equals to P inverse, or P inverse equals to P transpose. It is clear, all of you? Take a pic now, please. Take a pic fast. Completed?
Completed, ma'am.
Yes. Which is a capital P, and we need to write P inverse. What is P inverse here? P transpose only. Okay. And here, now, P inverse equals to P transpose. So, P inverse equals to, I'm going to transpose the given capital P matrix. And do the transpose of the given capital P matrix. It is clear? So, this one, first column be the first row, minus 1 by root 2, 0, 1 by root 2. Second column be the second row, minus 1 by root 3, minus 1 by root 3, minus 1 by root 3. Third column be the third row, 1 by root 6, minus 2 by root 6, and 1 by root 6. Clear, all of you? Now completed. Now P inverse completed here. Now we go for the last step. Sorry, that is the last but one. So that is the fifth step. What is the fifth step here? We need to check P inverse AP. Okay, now? So that is equals to what here? P transpose AP. Okay, now we are going to substitute P transpose. Minus 1 by root 2, minus 1 by root 3, sorry. P transpose here, this one only, na? 0, 1 by root 2, minus 1 by root, minus 1, minus 1 by root 6, minus 2 by root 6, 1 by root 6. It is clear? And what is capital A? 3 minus 1, 1, minus 1, 5, minus 1, 1 minus 1, 3. It is capital A into capital P, which is the capital P, minus 1 by root 2, 0, 1 by root 2. And here, minus 1 by root 3, minus 1 by root 3, minus 1 by root 3. Next, this one, 1 by root 6, minus 2 by root 6, 1 by root 6. By the multiplication of this, we can get the diagonal matrix. The diagonal matrix is this one, 2, 0, 0, 0, 3, 0, 0, 0, 6. Idella raskovalana? The principal diagonal elements are eigenvalues of the given problem. The principal diagonal elements. The principal diagonal elements are the eigenvalues, which is formed by eigenvalues. Compulsory ma. మీరు మల్టిప్లై చేయండి, మనకు వచ్చే రిజల్ట్ ఇదే. ఐగెన్ వాల్యూస్ కాకుండా ఏమీ రాదు. ఓకే, సో దిస్ ఇస్ ద ఫిఫ్త్ స్టెప్. నౌ టేక్ ఏ పిక్ I'm going to rub this part. ఇది ఆల్రెడీ తీసుకున్నారు కదా, ఇది 4th step.
Yes, ma'am.
అయిపోయిందా? Now I'm
Yes,
going
ma'am.
to, yes. Now here the last step, 6th step. Okay. Now write canonical form. What is the canonical form? Y transpose dy. Here assume, what we have to assume, capital Y equals to y1, y2, y3. We need to assume the one matrix. So that is a variable matrix which is different from the given capital X matrix, y1, y2, y3. Now y transpose dy. So that is equals to what here? Y transpose. Y is the this one. Okay. Y transpose nothing but y1, y2, y3 row matrix. Okay. Capital D is this one, which is the capital D. Okay. Substitute here 200, 030, 006. It is clear. Into capital Y, that is y1, y2, y3. Okay. Multiply first row with the first column, 2y1. First row with the second column, 3y2. First row with the third column, 6y3. Okay. Into y1, y2, y3. First row with the first column. It is clear. 2y1 into y1, 2y1 square plus 3y2 square, 3y2 square plus 6y3 square. So which is the quadratic form? What is the main difference between quadratic form and canonical form? Quadratic form having the multiple terms, multiple variables or product variables are there. And in the quadratic form, only squaring variables are there. And there is no product variables, which is the required canonical form. Which is required canonical form. So this is a procedure, all of you. Any doubts? If you have any doubts, please ask me and I will give the clarity. No?
Ma'am, notes.
Already I shared in the Teams app PDFs.
PDF, ma'am, there are limited only, like almost they are totally 23 or 24 pages. So that's all, ma'am.
Yes, and daily notes also I'm uploading, ma, in the
On Teams app.
class material.
Okay, ma'am.
Completed?
Yes, ma'am.
Next problem, write down. You do this one. Next problem, write down. Reduce the given quadratic form. Reduce the quadratic form x1 square plus 3x2 square plus 3x3 square minus 2x2 x3 to canonical form by orthogonal transformation. Do this problem, tell me the eigenvalues fast. I'm waiting. To write the eigenvalues, you have to tell. You have to do this problem, right?